Section 4.2, matrix multiplication. Your objectives is to simplify matrix expressions using the properties of matrices. Think about the essential question while you're watching the video and doing the homework. Homework is numbers 22 through 28 in the homework packet. Matrix multiplication. So in order to multiply matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. The product matrix will have the same number of rows of the first matrix and the same number of columns. So what we're talking about is if we have a 2 by 3 matrix and a 3 by 4 matrix. So what we're looking at is we want to compare the two innermost numbers. If these two numbers equal, 3 equals 3, then we can multiply those two matrices together. The resulting matrix will be a 2 by 4. Okay, so if we want to multiply these two matrices together, you first have to check to see if the two middle numbers are exactly the same. If they're exactly the same, then you can multiply those matrices together. And the resulting matrix will be the two numbers, the row in the first matrix and the column of the second matrix, a 2 by 4. Okay, so let A be a matrix N let A be a matrix M by N and B be N by P matrix. The product AB exists and we'll have dimensions M pi p. So they're saying if we have a matrix M by N and we want to multiply by a second matrix N times P, or by P, N pi P, we ought to take a look at the middle two. They are equal, so now we can multiply them, and the resulting matrix will be M rows times P columns. As long as the two middle numbers equal, you can multiply the matrices. That's why I like to write them next to each other and compare them. Determine if the matrices can be multiplied. So let's look at example 1. We have a 3 by 4 matrix and a 4 by 7. So 3 by 4 and a 4 by 7. The two middle numbers equal. So the dimensions of the, so yes, we can multiply it. The dimensions of the product is the first by the last. 3 by 7. All right, let's take a look at the next example. Next example, let A be 4 by 2, so write it 4 by 2, and B is 4 by 2. So we look in the middle here, they are not equal to each other. So it's not possible to multiply these two matrices together. So there is no product. You can just leave this blank, or you can say no product. But if you can't multiply, then there is no product. Let's look at the last example. Let A be 3 by 5. And the second one is a 2 by 3. I'm going to pause here, give you a few seconds to try it on your own. Okay, so we looked here in the middle. 5 and 2 do not equal each other, so no, the multiplication is not possible. All right, here's an example. Find the product of AB, if possible. So the first step that you have to do is determine if the product exists. Okay, so you have to take the dimensions of each matrix and compare the middle numbers. So in this case, the number of columns matrix A equals the number of rows in matrix B. Therefore, the product exists. So we have a 3 by 2 and a 2 by 2. 3 by 2 and a 2 by 2. So the middle terms are equal. So our product will be a 3 by 2. So it does exist. That's step one. Verify that we can multiply those together. Step two is multiply each entry in the rows of the matrix to each column of the matrix. So we're going to multiply 2 times 4. And that will put us into the first row and first column. Then we're going to add together 3 times negative 3. Okay? So we're going to multiply 2 times 4 plus 3 times negative 3. So that's negative 9 and 8, which is negative 1. Okay? And the sum or the answer will go in the upper left-hand corner, which is the first row and first column. Next step, we do it again for the second row, first column, or excuse me, first row, second column. So we have 2 times 1 plus 3 times 6 is positive 20. So again, you're going to take the first row of the first matrix and multiply it by each column in the second matrix. Okay? The next step is then you take the second row in the first matrix. You have negative 1 times 4 plus 5 times negative 3, which is negative 19. And it will always go second row, first column, second row, first column. Now we're going to multiply the second row times the second column, which is negative 1 times 1. So you take this, the row, times the first in the column, and then the second one in the row times the second in the column, and you add those together. And we get positive 29. So in the last row, the third row, we have 0, negative 2. And the first column again is 4, negative 3. So we're going to take 0 times 4 plus negative 2 times negative 3, which is positive 6. And then we're going to take the first row again times the second column. 0 times 1, negative 2 times 6, which is negative 12. So you can see our answer, as we figured out in the beginning, is a 3 by 2 matrix. The key here is when you're multiplying matrices together is to take the rows, the first row, times however many columns there are in the second matrix. If we had if we had more columns here, 6, 7, 2, 4, and it went out, I'm just giving you an example, then you would multiply this row times each one of these columns and you'd get an answer in those positions, okay? But we'll do another example here. All right, so what is the product of AB? First thing to do is check to see if it exists. So the first one is a 2 by 2 matrix. The second is a 2 by 2 matrix. So those are equal. So then we take the first and the last number, and that'll be our resulting product. So yes, it is possible. Okay, so what we want to do now is multiply. We always want to take the first row of the first matrix, because A times B. So we're going to take negative 1 and 3 and multiply it by the first column, negative 2 and 1. And we're going to add those sums together. So you always take the first times the first in the column. So that's negative 1 times negative 2 plus 3 times negative 1. Okay, so when we're multiplying the first row in the first column, it's going to go in the first row in the first column of our answer. So we're still going to multiply the first row. Now we're going to go to the second column. Negative 1 times 0 plus 3 times 2. So that's the first row times the second column. Now we've done the first row multiplication. Now we're going to do the second row. We're going to take 4 and 2 and multiply it by the first column and then multiply it by the second column. The key is that, again, 4 multiplies by the first number, 2 multiplies by the second number, we add them together. So we have 4 times negative 2 plus 2 times negative 1. I always put negative numbers in parentheses because it reduces the chance that you're going to make a mistake. Okay, so now we've got the second row, the second row, first column done. Now we have to do the second row, second column. So 4 times 0 plus 2 times 2. So we have the multiplication out of the way. We have the finding what the numbers are going to be multiplied together with. Now we just have to add and subtract. So the first row, first column is negative 1 times negative 2 is 2 plus or minus, excuse me, minus 3. So we're going to have a negative 1 in the first row, first column. Here is 0 plus 6. So we're going to have a 6 in the first row, second column. Negative 8 minus 2 is negative 10. And then 0 plus 4 is 4. So a little review. First of all, you have to test to see if you can multiply the two matrices together. Second part is to multiply them out. So we're going to do one more example. All right, first of all, we have to see if it exists. So we have a 2 by 2 and a 2 by 3. So in this case, the 2's are equal, and our resulting product is going to be a 2 by 3. I'm going to stop right here, and I'm going to do it on part 2. I'm going to do example 5 on part 2 of the section 4.2.